Hello, Year 11, and welcome to another exciting class where we get to draw some more graphs. The first one we're going to look at today is graphing exponential functions. Now, exponential functions are in the form y equals a to the power of x. So here's some examples that you could see. Y equals 2 to the power of x. Something like y equals 5 to the power of x. Something like y equals 5 to the power of 3x, take 7. You could have y equals minus 2 to the power of 3x. It doesn't really matter what the number is as the base. What matters is that x is part of the exponent or the power or the index, because x being in the power of the exponent makes it an exponential graph. Now, exponential graphs have one horizontal asymptote, and it's always located on the x-axis unless the graph is translated or moved around. So let's get into what our first graph is going to look like. It's probably the easiest exponential graph, and that's y equals 2 to the power of x. Now, what we want to do is you want to look at our table of values, and we're going to plug in the different x values into y equals 2 to the power of x. So the first one is y equals 2 to the power of 4. Now, if you put that into your calculator, or if you do it in your head, it's 1 over 2 to the power of 4, which is 1 over 16. Let's write it as a fraction, not a decimal. 2 to the power of minus 3. 2 cubed is 8, so 2 to the power of minus 3 is 1 over 8. 2 squared is 4, so 2 to the power of minus 2 is 1 over 4. 2 to the power of negative 1. 2 to the power of 1 is 2, so 2 to the power of negative 1 is 1 over 2. Anything to the power of 0 is 1. 2 to the power of 1, 2 squared, 2 cubed, 2 to the power of 4. Now, assuming each square on my grid is worth 1 unit, so we've got 1, 2, 3, and so on, and 4. And every square is worth 1 in the y direction as well. We can now plot our graph. So, negative 4 up 1/16. Well, that's not very high. I'm just having a wild stab in the dark guess there. It's not really accurate. Negative 3 1/8, still pretty low. Negative 2 up 1/4. Negative 1 up 1/2. 0 up 1. So the next one will be 1 up 2. Next one will be out 2 up 4. Out 3 up 8. And the last one out 4 up 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it would be there. So our graph is going to look something like this. And it's a curve. And there it is. Now it's important that we highlight the y-intercept, which is at 1, and there is a horizontal asymptote at y equals 0. That's another name for the x-axis. So there is our graph of y equals 2 to the power of x. Next type of graph we're going to look at is a log graph. Now, what's important is on your calculator to understand that there are 2 log buttons. One looks like this, and one looks like this. Some people think it's IN, but it's actually lowercase l. Now, at the moment, we're interested in using that button for today. So we're using the log button, and it's actually log to base 10, but we'll talk about that when we actually do some more logarithms later. So let's go and do the first one. The log of -2 doesn't work because you can't take the log of a negative number. We'll talk about that later. Try the log of -1, you get a math error. Try the log of 0, you get a math error. They don't work. Now, if you try the log of 0.5, put that into your calculator and you'll get a decimal that's minus 0.301029995. I'm going to just round it to minus 0.3, but it does go on forever. If I try doing the log of 1, I get 0. If I try doing the log of 2, I get plus 0.3 going on forever. If I try the log of 3, I'm going to take it to 2 decimal places for this one. It'll be 0.48, and it goes on forever. That's only rounded to 2 decimal places. And the log of 4 is 0.6. I'll take that to 1 because it's 0.60. So there are some points. Now, they're not going to make a lot of sense, those points, but let's try plotting them anyhow. If we go out a half and down a third. Now, before we get too carried away, if each square represents 1, go out a half and down a third, that means I've gone down point, let me start that again, out 0.5, down minus 0.3, not a third, I shouldn't have said a third. Out 0.5, down 0.3, roughly about there. The next one, 1, 0. The next one, out 2, up 0.3, about there. I'm assuming every square is 1 unit. Out 3, up 0.48. Out 4, up 0.6. Wow, that doesn't really tell me a whole lot, does it? Now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's go out to 10. If I was to do the log of 10, so do the log of 10 on the calculator, you get 1. So that means when I go out there, I get 1. What's going to happen if I did something like the log of 0.1? So we try that, the log of 0.1, and we get -1. Wow. So what I'm actually getting is this. Graph which is growing so slowly, it's logarithmic growth, and I have a vertical asymptote. The y-axis is a vertical asymptote, so there's a vertical asymptote which is the y-axis, which is another way of describing x equals 0. So realistically, this is the shape of a log graph. And it goes through at 1, which I need to mark on my graph there. Okay. Now, the domain for this question. The domain, well, doesn't go forever to the left and right. The graph only exists to the right of 0, not including. So that's the domain. As for the range going upwards and downwards, the graph heads downwards forever, it's asymptotic there, and it heads upwards forever. It's just climbing very, very slowly. So the range is all real y values. And we continue. Now we're going to look at cubic graphs. Now, cubic graphs can be written in a general form or a bracketed form. So, if they're in bracketed form, they're actually easiest to graph because you can actually let y equal 0 and you can read off the x-intercepts straight away. And that's what we're actually trying to get if we can. Now, what we also need to notice is the number in front of x cubed, if it's positive, my cubic is going to be heading upwards to the right-hand side. If it's negative, it's heading downwards on the right-hand side. So let's try drawing a graph first. Y equals x cubed, take away 1. Now, if x is minus 3 cubed is minus 27. Take away 1 gives minus 28. When I try the next x value, minus 2. Minus 2 cubed is minus 8, and minus 8 minus 1 is minus 9. Then I try negative 1. Negative 1 cubed is negative 1. Take away 1, you get negative 2. 0 cubed, take away 1, gives negative 1. 1 cubed, take away 1, gives 0. 2 cubed is 8, so 2 cubed take away 1 gives 7. And 3 cubed is 27, so 3 cubed take away 1 is 26. Now, I can't plot negative 3, negative 28 if I'm going to use 1 for each of the x values, so let's not worry about it. Let's go straight to negative 2, 9. So go left 2 and down 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll put a marker there. The next one we're going to look at is negative 1, negative 2. So go left 1, down 2, we'll put a marker. 0, negative 1, 1, 0, 2, 7, 2, 1, 2, 3, 4, 5, 6, 7. And 3, 26 will be way off the graph, so I can't fit that. So this is my graph. It goes something like this. Here's a cubic graph. So a cubic graph goes for y equals x cubed. It's your basic cubic, and it goes something like an upside down parabola and then a right side parabola, and our graph is exactly the same as that, pushed down 1 unit. So it's at minus 1 there, and that's at plus 1 there because it got pushed down. Y equals minus x cubed would be exactly the same, but it would go the other way. Now the domain and the range for this particular question. So let's get the domain first. Domain, all real x, because it spreads forever to the left and the right. As for the range is all real y values because it heads upwards and downwards forever. So there is our cubic graph. Now, when there's a cubic graph where it's just x cubed and that's it, the graph is pretty much like this, or like this, or something like that. But the moment I have other x terms, the graph becomes more like this, or more like this. And we'll start to see what that actually means soon. Okay, here's our next one. We know it's a cubic graph because if we multiply it out, we've got an x, and an x. And when you multiply these brackets, you get the x squared, and that x times that will give my x cubed. So it's a cubic. How do you find an x-intercept? Well, to find an x-intercept, you let y equal 0. So for this question, you'd get x-intercepts of 0, 2, and minus 1. So 0, 2, and minus 1. How do you find a y-intercept? Well, to get a y-intercept, you look at the question and you let x equal 0. Now, it doesn't really matter what the brackets equal. That 0 out the front's going to times to them, and 0 times anything is 0. So it goes through the y-axis at 0, which we've already got there. Now, because every one of the x values is positive, I know it heads upwards to the right, so my graph goes something like this. Now, this is just a rough shape. I really don't know how high or low it goes, and I'm not really worried about that at this stage. There's my rough sketch. The key thing is being able to graph the intercepts. These 2 points here, the high point and the low point there, they're called turning points, and we'll find those later on when we learn how to do calculus. but that's for another time. So for the domain, well, this graph heads forever to the left and forever to the right. So for the domain, it is all real x values. And for the range, the graph heads down the page, or down the graph forever and upwards forever. So the range is all real y values. All cubic graphs will have a domain of all real x values and a range of all real y values. So let's do some really quick sketch of some cubics. And we've got to state the domain and the range for these ones. Now, the idea is to do a quick sketch. So for this one, I can tell if I set y equal to 0 to find the x-intercept's at -3, +1, and +2. So I'm just going to go -3, 1, 2. How do you find a y-intercept? Well, you let x equal 0, so that bracket becomes 3, that bracket becomes -1, that bracket becomes -2. 3 times -1 is -3, times that by -2 and you get +6. So it's not drawn to scale. I'll come here and I'll put a +6. Now, I know this graph is positive because each x term is positive, which means it's heading upwards to the right, which means it comes from upwards, goes down, up and through, and back down, and there's my sketch. For this one, the domain, all real x values. Well, that's not very neat with my writing. And the range is all real y values. And it's going to be the same domain and the same range for every one if it's a cubic graph. Let's go to part B. Now, this is a bit of a trick question. Let's see if we can read off the x-intercepts. Well, we know there's an x-intercept at +3. There's also an x-intercept at -1, but this little squared means that the question is actually this. That's what the x plus 1 in bracket squared means. That bracket happens twice. Now, to graph this, we know that it goes through the x-axis at -1, but it does that twice, which means it won't cross through that. It actually bounces off it, as the rule we're going to see in a moment. We know it goes through also at x equals +3, because that term is positive and that term is positive. It's a graph that goes, actually before we do that, let's find the y-intercept. You find the y-intercept by letting x equal 0, so that bracket becomes 1, 1 squared is 1. That bracket becomes -3, 1 times -3 is -3. So we know it's positive, so it's heading upwards on the right. And it bounces off. When you have a squared, that means that bracket there is the bracket that bounces off the x-axis, if you like to talk about it like that. Now, part C, because it's very similar to y equals x cubed, which we know looks like this. Well, this is the same graph, but it's pushed right 1 unit. So we're now here at 1, so it'll come down. And there's my graph. Where does it hit the y-axis? Well, you let x equal 0 to find a y-intercept, and you get -1 cubed, which is -1. So that's at -1, that's at +1 there. Let's have a look at part D. Part D crosses the x-axis at +4, at -5, and at 0. So -5, 0, +4. Where does it hit the y-axis? Well, you let x equal 0, you'll plug that in. 2 times 0 is 0, 0 times anything is 0. It's going to hit the y-axis at 0. This graph, because that x is positive, but this x has a minus 2 in front of it. One of them is negative, means that it will be heading down on the right-hand side. And so there is a sketch of my cubic. Now, the domain and the range is the same for all of them, all real x values and all real y values for part A, part B, part C, and part D. Righto, let's now graph another cubic, and I want you to be really careful before you don't copy this one down yet, because I'm actually going to have, I'm going to erase it, but this is what y equals x cubed plus 5 looks like. This is what we're being asked to look at originally. Well, y equals x cubed we know looks something like this. So y equals x cubed plus 5 will be the same one, but pushed up 5. But here is the problem. I only want to graph the function. I only want to include my graph going from -1 through to 3. So what I'm going to do is undo my graph, and I'm going to do this. Table of values, -1, 3. So let's have a look at it. If I'm using x as -1, -1 cubed is -1. -1 plus 5 gives me 4. For the next one, 3 cubed, I'm using 3 cubed is 27, plus 5 gives 32. Which means I can go -1 up 4, which is maybe about there. I'm going to go up here to 5. I go out 3, up 32, which I might say is there. It's not drawn to scale, and it doesn't have to be. Now remember, I said y equals x cubed plus 5 goes something like this. Goes through 5. So, graphing between -1 and 3, my graph will look something like this. So, what's the range? Because that's what the question asks you to do. It says find the range. It didn't even ask me to graph it, but by graphing it, I can visually see the range. My lowest point has a y value of 4. My highest point has a y value of 32. Range are y values, so there is the range for my graph, from 4 through to 32 inclusive. So let's look at example 5. Now we've got a graph y equals the square root of x take 6. Now let's just see what happens for a second here. If I let x equal 0, what's 0 take away 6? -6, because I want to find the y-intercept. So how do you find a y-intercept? You let x equal 0. So you let x equal 0, you get 0 minus 6, which means you end up with the square root of -6, which doesn't make sense. You can't take the square root of a negative number. So whenever you have a square root sign in the question, you need to be able to look at it and recognize that the bit under the square root sign has to be greater than or equal to 0. And if it is, then you can rearrange it and recognize that this graph will only make sense when the x values are bigger than or equal to 6. Now if that's the case, then I can just take a couple of values. I use 6. I might go 10, and then I might go, look, you can go 6, 7, 8, 9, 10, you can go 6, 10, you can go choose any values you want, but the next one I'm going to choose after 10 is 15, and you'll see why in a moment. So let's try plugging in x equals 6 to the question. If x is 6, 6 takes 6 is nothing, and the square root of nothing is nothing. Now let's try 10. 10 takes 6 is 4. What's the square root of 4? The square root of 4 is 2. Let's try another one. 15. What's 15 take away 6? 15 take away 6 is 9. What's the square root of 9? 3. See, here's one more I could have chosen that gave an easy answer. 7. I should have put that in earlier. What's 7 take away 6? 1. And the square root of 1 is 1. Now if I chose other values, let's say I did choose 8. It would have been the square root of 8 take away 6, which is 2. I would have got square root 2, which is about 1.414, and I didn't really want to go in the decimal direction if I could avoid it. So let's have a look at graphing this thing. The first point that I'm going to graph is 6, 0. The next one is out 10, 7, 8, 9, 10, up to somewhere like that. I'm just having a wild guess. That's out 10, up 2. The next one out 15, let's say up 3. Just a wild sketch. So that's that one done. This one out 7, up 1. Could go out 8, up 1.4, it doesn't really matter. And the graph looks like that. Now what you probably don't recognize here is it's actually a sideways parabola, but it's only the top half of it. So imagine the sideways parabola that looks like that. It's only this part of the parabola. Now what's the domain? Well, the domain is everywhere to the right and including 6, because it starts at 6 and it goes off to the right forever. What's the range? Well, the lowest y value is 6 and it goes upwards forever, so it's y. I should say the lowest y value is 0 because that's the point 6, 0. So it's y is greater than or equal to 0. Well, that's the end of that exercise. Enjoy the experience of working through some questions. Bye for now.